Hi, I'm Paul from Team Economists, and I'll be giving you an overview of our project and team. I'm sure you've all heard of Linktree, which provides a platform for users to create digital identities for their social properties and connect to their audience through a single link. The aim of our project is to borrow the business idea to practice new technologies and understand the tools and process that underpin the practical aspects of software development. To build our backend, we use Nest.js to build our GraphQL server, Prisma ORM to interact with NoSQL database provided by the MongoDB Atlas. We also implemented JSON Web Token authentication with Possible.js. As for the front end, we use Next.js to build our application, Chakra UI to bootstrap our development process, and Storybook to manage our UI components. React Query was used to manage our server-side states, Dustin was used to manage and persist client-side states, and React Context API was used where locally scoped state management is needed. To ensure the stability of a project, we are attempting a testing trophy approach and building our testing solution using Cypress and React testing library. Leveraging the benefits of serverless functions, we have used the serverless framework to offload the process to send email, process and upload user avatar, and resolve multiple asynchronous API calls to the third-party platform, AWS Lambda for this instance. Then there's also the React hook form for form validation, React I-18 Next, and Next.js internationalized routing for localization, and GraphQL codegen to generate type-safe query and mutation hooks. You can check out the information board in our Gather room to view some of the dashboards. In our team, we have 5 developers, 5 devs, 1 UI, and 2 BA. We follow the agile software development lifecycle using Jira to plan and track our progress. Once an issue on the Jira board is assigned, the assigner will create a feature branch from the develop branch, push commits, and open up a pull request while filling a checklist of our pull request template. To control over code quality, we also implemented GitHub Action. When the pull request is open, GitHub Action will automatically run linter check and unit tests before attempting to build the application. When the reviewer approves the pull request and conversations will resolve, the feature branch gets merged into the developer branch, which targets our UAT environment. And finally, when the features are tested, we will then merge the main branch, which targets the production environment. To quickly explain our core feature, referencing Linktree, the user will first start by creating an MP link on the profile. When the user enters the URL they want to share, the URL will be sent to our backend server, which will run through a third-party API called jr-mel-admin to validate if the URL is reachable. Once it's validated, jr-mel-admin will help us extract the metadata from this URL and populate the title with its page title. Then we attempt to resolve the type of the URL, whether it's video, Pinterest, or a generic link, and designated with the corresponding type in the database. Once the mutation is finished, the front end will invalidate the query cache and fetch a new copy of the profile items, rendering the corresponding variants of the UI component given its type. To utilize the full potential of Next.js data fetching and pre-rendering features, we have implemented our project page with static site generation. Next server will pre-render the page by fetching information through our Lambda function. Then it will generate a static page that can be served almost instantaneously on user requests. Public profile pages will implement with server-side rendering instead to shift the workload of clients while ensuring data is always up to date. We have also integrated an NFT minter into our project. Users can connect to their MetaMask accounts and send transactions to a smart contract on the Rinkeby Ethereum testnet to mint image tokens that are randomly generated from hash libs. These tokens can be used as user avatar. Users will also be able to view or trade their tokens on OpenSea. And that's the high-level overview we want to share from the developer perspective. Now, Kelvin will show you our project architecture.
Thank you, Paul. Hi, everyone. This is Kelvin. We have the architecture diagram in the production environment here. To obtain the benefits of the CDN network and the functionality of server-side rendering, we deployed our front end in Lambda Edge. User will be directed to the closest CDN server and access our front end. The static content was cached at AWS CloudFront. Server-side rendering pages were compiled by the Lambda Edge functions in the CDN server. SSL certificate from the AWS Certification Manager was used to enable encrypted web connections. To achieve high availability, scalability, and reduce the difficulty of cloud migration, we deployed our backend on the EKS. The backend node was deployed on the private subnet to ensure the security of application from vulnerable attacks. As the private subnet does not have the internet access outside the VPC, we deployed a NAT gateway to allow the backend port to pull the server's image from ECR and access other third-party services. The NAT gateway will ensure the backend application has secure communication with the internet. The user will connect to the backend port through the application load balancer. User requests will be distributed by a load balancer across two availability zones. The Kubernetes horizontal auto-scaling and AWS EKS cluster auto-scaler ensure the backend could handle large request traffic. We deployed the API gateway and Lambda function to process and store users' avatar in S3, handled email communications, and resolved multiple asynchronous data fetching operations. The connection between the backend and the API gateway is also secured by SSL certification. For the data storage, we chose the MongoDB Atlas as our application database. All of the cloud infrastructures were deployed through Terraform to achieve efficiency and consistency. The following graph shows the project architecture in the UAT environment, with similar deployment in two availability zones within the Sydney region, such as the use of application load balancer, NAT gateway, encrypted connection, and deploy applications in private subnets. In addition, a lock-in feature in the application load balancer collects the access log and stores it in a private S3 bucket. The access log contains information such as the latency, request paths, and service responses, which is critical for us to analyze the behavior of applications in the current environment and minimize the occurrence of failure in the production environment. Next, please. We chose the GitHub Action as CI/CD pipeline tool for the production environment. After we validate the application in the UAT environment, we will trigger the production CI/CD pipeline manually. For the backend, GitHub Action will run the static type checking and automated testing. After that, it will build and upload the Docker image to the production ECR. Eventually, the backend image will be deployed in EKS by utilizing Terraform. The front-end pipeline is similar to the backend. The difference is, after testing, the pipeline will trigger the serverless Next.js framework to update the Lambda Edge function and static contents in CloudFront. Next, please. The EKS cluster monitoring was handled by Prometheus daemonset. It will collect and store the cluster resource metric. Then we utilize Grafana to visualize cluster CPU, memory, and storage usage. Next, please. The cluster log was collected by the FileBit daemonset. The EKS stacks further response for log data processing, indexing, and visualization. That concludes our presentation. Thanks for your attention. Norris will now give us a quick demo of the project.
Oh, okay. There you go. Right. Thanks, Kelvin and Paul, for the awesome presentation. For this demo, we'll just quickly register our site as a new user. and then we'll add a few links to our profile, and then share the link to access it in our chat. Let's start by entering our user detail here. Since I already have an account, so I'm just gonna give it a different nickname. It's 25th of August. And for my email, let's use the same address to do the trick here. And the most secure password in the world, password@1, and hit sign up. And there we go. Okay. After the user sign up, we're taken to the onboarding stage where they can enter give the profile a display name. And this one can just follow the same pattern, call it e-commerces, 25th of August, and then pick a category that best describe our profile and hit continue. So after the user went through the onboarding, we'll send the email to their inbox. There we go. Where the user can click on this link to verify their account. With their account being verified, the user will be able to access the admin panel where they can add the links and stuff. To quickly demo our NFT features, since it does take a minute to mint the NFT, so we will start by getting the mint going. Let me just make sure I have the right password. Oops. Nope. There you go. Cool. Now I've connected my wallet to our sites. We will display the list of tokens the user already possessed, collected in this list here, and the user can click this button to mint an NFT. All right, let me confirm the transaction here. Right, okay. The transaction is submitted, and it should take a minute or two before the token gets back into our wallet. While that's happening, let's add a few links to our profile. Currently, our site supports three type of link. It's either from YouTube, Vimeo, or Pinterest. Oh, actually, it's 4 types of link, and also anything other than that. So let's start with YouTube. Let's add my favorite music video. So let's create an empty link template. Oops, no, that's Notion. Sorry, one sec. Let me quickly grab the description of the screen and paste it in here. And let's grab the URL and put it in here. Right. Once both fields populated, our backend will validate if this link is ready to be displayed to the world. Once it is, we will the query cache will refresh, and you will be able to see the link on your right-hand side here. And then next, let's add a Pinterest link in our profile. With some of the links, since URL meta will help us automatically extract metadata from the site, we'll save the user's hustle to enter the title here if it has a really long title there. And lastly, let's add a generic link, which is a Pineapple Wikipedia page. Right. Now that's all done. We have 3 links in our profile. On top of that, we can also add in a quick description so that others can know what our profile is about. Also grabbing that off our screens. Oops, hitting a wrong shortcut. Right, done. Now our profile is ready. The user can click on this, open the share panel, and either share our link via the QR code or simply just copy it and paste it in our chat here, which you will be able to see. Oops, not send it to nearby, send it to everyone, which you'll be able to click on in the chat right now. And let's check if our NFT has been minted. Let me check my notes. Yep, okay. So as you can see here, we now have 13 NFT in here. And if I'm not mistaken, it should be e-commerce to suck number 28. Since we're using the free version of the Pinata service here, it's sometimes a bit slow for us to get the image of the service. But if you, oh, there you go. Tickle the devil, it's already here. Once the user has connected the token, they can also connect the wallet. They can also set an NFT as the avatar here, which can be accessed via which everyone else can see as well. And you can also click on this button here to view your token on OpenSea. Everything because we don't have the budget to deploy our NFT tokens to the mainnet. So as of this stage, you can only do all of this in the Rinkeby or Goldie testnet. And now our profile is completed. Let's click on this link to see if everything works as expected. Video work. Let's not play this right here. And we can the public can view our Pinterest link in here as well. Nice. And they can click on the Pineapple Wikipedia to know everything about Anonymous commerces. And that is the end of our presentation. Thanks, everyone.
Thank you, team at Commerce. This is really wonderful presentation. Okay, let's just go into the Q&A section. Please use the checkbox to ask anything you want to know about a team. And I'm probably going to wait for like 1 minute. And if there's no question at the moment, I'm going to skip to the team 3. Okay, so right now, team 3, you can just get prepared. Okay, seems like our guest is going to wait the question to the breakout room section. Okay, let's welcome our team 3 booking lead. Oh, and at the meantime, team 4, Tech Master, please get ready.
Can you hear me? Yes. Can everyone hear me? Yes.
Yeah.
Okay. Hi everyone, we are Team Booking Lab. It's an honor for me to introduce our team and project. Let's get started. Our team has 8 developers, 6 DevOps, and 2 tutors. For our project Booking Lab, it's an online booking system fit for all service-based industries and specifically designed for local small business. The website offers you more flexibility rather than other products on the market. Take booking for example. The start time and duration of service is changeable and in a unit of minutes, so the customer can have more flexible options than using fixed time slot system. In addition, it is fully functional, including following features: search store, add store to favorites, booking, manage booking, edit profile and upload image, create and edit store, create, edit, delete service, edit calendar. Next page, please. Manage orders, register and login protection, and error handling. Now let's move on to the technical stack. In frontend, we use HTML, CSS, JavaScript, React as basic, and we use Stack components and MUI for style, RTK query for fetching data and API interaction, Formic for form validation, Chart.js for data visualization. In backend, we use RESTful API, Node.js, Express as basic, MongoDB and Mongoose for database, aggregation framework for building search query across multiple tables, Joy for data validation. Next, let's turn to tech challenge. Firstly, we built a double check system for booking availability. When selection, only the available start time and duration will be displayed for customers, and the system will recheck after order submit to avoid changes caused by long stay on the page. Secondly, we made a customized calendar in frontend. The calendar was built without using any third-party library in order to perfectly match with our project architecture. In backend, we developed a synchronization mechanism for database. So that was a brief introduction on the project. Now, Derek will talk about system design.
I'm Derek, and I'm going to talk about how our booking system works. Our system includes business path and customer ordering path. Business path is designed for business owners. When business owner at a time interval, it will be divided into many time slides. When they add business time in service calendar template, some extra information will be added into time slides. Booking record will be created only when customer take an order in certain service. Customer ordering path includes 4 stages. The first one is query booking information. It means that only available service and time will be presented to customer. Then customer select service and time, make a query booking. Then the system will make an availability check based on booking record or service info calendar. The last stage is decision making. If the decision is success, customer booking information will be updated into booking record, and an order will also be created. Finally, the customer will get the result. Let's move to our Devops team now.
I'm from the Booking Lab Devops team, and I'm excited to present to you. For our Booking Lab project, we use a three-tier infrastructure. First is the presentation layer. We deliver our service to the S3 bucket and use the cloud form as CDN to promote a consistent and fast visiting experience. The second is the application layer. We deploy our BAM to a single region, meaning different availability zones to prevent service failure. We also use application load balancer to distribute traffic between tasks when overloading for higher availability, and to continuously check container status, and then rerouting traffic to the working task for fault tolerance. To respond to real-time traffic automatically, we use auto-scaling to easy scale ECS bucket tasks. When the CPU utilization reaches a certain number based on our business group, and to replace unhealthy containers to prevent application failure. In addition, we use cron to allow service go to sleep during low traffic time to reduce our business costs. For security management, we config bucket tasks in private subnet to disable direct public access and to only allow application load balancer and negative weight to our tasks in order to enhance higher security. For monitoring, we use CloudWatch and ELK to collect the data source and set the Grafana dashboard based on forgotten signal to monitor latency, traffic, saturation, and error. The last one is the database layer. We choose MongoDB Atlas as our application database and store MongoDB credential to S3 bucket to enhance database security. We choose Jenkins as our CI/CD tool. We implemented front-end and back-end pipeline for each development and production environment. For both front-end and back-end pipeline, we set the auto trigger to build each time when new code merge to the target branch. Jenkins pipeline, we fetch the script file from the source code to install package and build artifact, and then deploy it to the S3 bucket as a static website page. Also, Dockerize back-end application and build the Docker image, then push to ECR and update ECS service. All of the AWS cloud infrastructure was deployed by Terraform. We use Terraform to modelize different parts of our formal code, and we can reuse them for other projects. We use S3 bucket to back up state file and DynamicDB to log in state. For all the data security and credential in this pipeline, we implemented environment variable for all of them, so there are no credential written in the source code. The highlight of our project are higher availability, higher security, auto-scaling, and monitoring to promote better business performance and reduce business costs. Thanks. Next is the demo video display.
Okay, next I will show you a video about our demonstrations of our features. everyone. I am Xiangji. You can also call me Sean. I graduated from University of Adelaide, learning computing and innovation, and now I'm working in Booking.net team as a team leader. In this project, I have finished the user APIs and authentication system in backend, and finished the login and register system in frontend. Working in Booking.net was a precious experience for me, and now I'm looking for more opportunities.
Hi, I'm Seven, graduated from University of Tasmania, studied Master of Information Technology and Systems. In Booking.net, I work in front-end and develop 5 pages, including booking page, store setting page, store list page, error page, and landing page. I really enjoyed teamwork and gained a lot from our project. Thank you.
I'm Derek. I designed our project architecture and call algorithms. For backend, I developed our call systems, including our calendars, booking system, synchronized update mechanism, and searching system. I also developed other simple functions like DIUD logics, and I also built our database independently. For front-end, I developed our calendars. Besides, picture upload and storage system with AWS is also my work. Thank you.
Sorry, due to the time limitation, I will jump to the function demonstration directly. Hello, everyone. This is the video to show our project. First, type in the URL of our website, which is bookingnet.com.au. And then you can see it's our landing page of our website, which includes a search function and boxes to jump to the modules. And in the modules, there are many stores to show in our website. Okay, next I will show you how to use our search function. For example, I wanted to search a dining store in today in Victoria State and click search. And I found 3 results in this page, and I can click learn more to enter to this store page to show the information of this store. Okay, next I will show you how to make a booking on our website. But first, you need to be a user of our website. So first, I will register a new account for this. Enter the phone number, email, and also password. Okay, now so we can log in into that user. Okay, so now we are the new user for this website. Now we can start booking. First, choose the date is today and service to people. And this diagram shows how many times we can book in this store. So choose one time to our duration, and the end time will be automatically calculated. And choose next, enter my mobile. And next, submit. Now we make our booking successful. Okay, next I will show you some features for the customers. First, click on the avatar, and it will show the user panel. And click into My Info, then you will go into your information second page. Then you can change your information here. For example, change the city to Adelaide, and postcode to 5000, and state to SA, and click Save. Then your profile is updated. And also, if you want, you can upload an image as your new avatar from here. The next function I will show you is the booking management system. Choose the user panel and choose My Bookings. And then you can see this is the booking we just made. Okay, then I will show you another function of user. Firstly, get back to landing page and choose one store. And you can add it to my favorite. Then you can check it using user panel to my favorite store. And refresh the page. And you can see it's added to your favorite. Okay, let's go back to Booking.net landing page. And then in order to show you more business functions, I will choose to log out and log in another business account we have prepared before. And as you can see in the user panel, there's another function called My Stores. And choose it, and we can see you have 3 stores. And this is the one we just had the booking. Click on the View Store Bookings. And then we can see the newest order is here. And as a store owner, you can confirm or decline this order. Okay, go back to the store setting page. Okay, then next I will show you the most important feature of our website, the calendars for the stores. First, going to edit store information, and you can see the service list, service information, and the store information. In the store information, we choose the calendar, and it shows the business time for this store. We can add any business time as we want. For example, 8 to 10. And as you see, it appears here. And also, if you add any time between any two periods of business time, it will automatically merge them together. And finally, you can also delete any business time as you want. In addition, the business owner can register a new store by clicking here. After you input all the information is needed, then you can register a new store on our platform. Now go back to the store landing page. Okay, then for every service, there's also a calendar. And then if the calendar is empty, it can synchronize the business time from the store. Yeah, as you see, it will automatically fill the time with the business time. And also, you can edit the service time as you want, but it cannot get out of the business time. For example, in the calendar, here we type the time that is not in business time, and there will be a sign that warning that shows it's not in business time. And finally, if you change anything, calendars in this service list, for example, it will sync all the records in our database. For example, from here, since 6 to 8, this time will be synchronized to all the records in our database. And also, if you edit it and delete it, it will also synchronize all the records. And in addition, there is a warning system in our database that if there is any order already set during this time, you cannot delete this period of business time. Okay, and last, the business owner can also change the store information by clicking the edit button here. For example, we can change the name of the store to here and click save. As you see, the store's name has changed. Okay, let's change it back. Okay, that's all the main functions of our website. Thanks for watching.
Thank you. Thank you, Team Booklet. As the time consideration again, I have to welcome our Team 4 Tech Master. And at the meantime, Team 5, Heartbeat, please get ready.
Okay, test. Okay. So are you ready, Belinda? Belinda?
Full screen.
Yeah, sure.
Thank you.
Okay.
Hi, everyone. Thanks for coming. My name is Belinda. I'm a business analyst in Tech Master's team. It is my pleasure to present to you our project TechScrum. And my role in this project includes analyzing business requirements and working with the IGL team to define the problem and drive solutions. I'm also focusing on sprint planning and manage project delivery. So first of all, I will give a quick introduction of our project. And our project TechScrum is focusing on creating a platform management, a project management platform. So at this point, TechScrum is mainly targeting on computer software industry, specifically for small to medium businesses. And our platform allows your team to be able to view projects together and communicate on the platform. So further, this provides team members to be able to create cards that provide details for each task that can also be assigned to specific members to work on. So you're also able to monitor and track every step of the process. So as you can see, here are some highlights of our key features. We have register and login system. A new user can sign up for a new account via email verification. And we also have the user profile, and each user will be able to edit their own personal details. And we also have the project list. You can see the existing project list, and you can also create your own project. So a project will be displayed in a board view, which is basically a Kanban board. And on each board, you can add new tasks or manage task details, such as due date, comments, or assignees, etc. So more importantly, by implementing RBAC and SaaS system, we managed to build multi-tenant architecture to achieve multiple members working on the same project simultaneously. And we're also able to customize permissions for different roles. And currently, we are in the phase 1 of this project. This project will continue to be developed. So that is an overall summary of our project. Now I'll passing it to our developing team to cover our project in more detail. Let's welcome Emil.
Hi, everyone. My name is Emil, the leader of the developer teams. As you see, it's all our teammates. If you are interested, just don't hesitate and contact us. All of our information will be shown in the About page of the Telegram. So let's move on. First, I will talk to you about test stack. In the front end, we use React with TypeScript with very important library, which involves SAS, Context API, ASIOs. In the back end, we use Node.js with Express, and we use very important library as well, which involve JWS, Cross, and so on. In database, we use MongoDB. We also use several tool to support our development. We use Bitbucket to ensure the version control, and we're using Jira to ensure we have agile development methodology. So let's move more exciting part, the demo part. Okay, today the lineman wants to create a new project. So he needs an application to make a project management. In Telegram, the main customer is about small and medium-sized business. So it will be the perfect choose. Let me go to the register page. After input the organization name and the email, hit the register button. The verified email will be sent in the Lightman email box. We'll go to Lightman email and click the confirm button right now. Then you'll go to system feed. As you see, they are perfect on our URL. It's very important, but let me talk it later on. After fill the name and the password and click the register button, now a new account will be ready for the Lightman. On the right and top hand side, Lightman can change his profile. When you click the profile button, it will be in the profile page. We can update the personal information here, which involve avatars. When you click Save Change button and click Confirm, all the personal information will be updated. Now, let me create two projects, with the name Project 1 and Project 2. As you see, when you click Save button, a project will be created. But obviously, Project 1 is not official enough, so Lightman want to change the name to the job pin. So when you click Save button, you see the project name has been changed. Lightman can delete the project as well. We use the soft delete in there. On the left-hand side, Lightman can create a shortcut. I try to create Google link to help her to search the information more easily, or even remote or edit the shortcut. Meanwhile, Lightman can create the task as well. In the create task page, you can see the task should involve summary and description. When you click the create button, the task will be created. We can change the data by drag and drop. Lightman also can add a label or add any information in the task detail page, and the old task page will be updated in real time. When Lightman creates a lot of tasks, he realized it's very hard to hold the project by himself. So the Lightman go to the road page and ensure all of the accessory is road, with 4 default roads in there. Then Lightman go to the member page and add the new member with the Kathleen. First of all, Lightman should input Kathleen's email and set the role for the Kathleen. In here, he sets the developer in there. When he click the add button, the invite email will be sent to the Kathleen. Then we move to the Kathleen's email. As you see in the email, when Kathleen hits the confirm button, it will move to the register page. When Kathleen imports her name and the password and click register, account is ready for her, and she can see the job pin and all the tasks. Sometimes, in the admin side, when you refresh the page, you can see Terry already in there. Sometimes, admin want to build the progress of the Telegram. So, as the administration, I have to send the invite to the admin. As you see, the admin should be registered. It's because we use the SaaS delivery model, so the data is completely isolated for each company. When admin registers successful, he can overview all the project and tasks in the Telegrams. That's all of my part. So it's your turn, Leos.
Oh, good. Thank you, Email. Good evening, everyone. I am Lois, a member of TechMaster DevOps team. Next, I will introduce the architecture of the project. In this project, we use 3-tier architecture. Let's go through them one by one. For the presentation tier, we configured multiple resources to support the content of the website. The S3 bucket is used to host our build files as front-end solution. The code front supports to deliver contents to our users, which decreases the latency and maintains a high data transfer speed. The firewall helps protect the software against common web exploits that affect the availability and security. The Route 53 is used to manage the domain name from the web browser to the application. For the application tier, our application is implemented as ECS bucket, which holds tasks in 2 different zones in order to provide high availability. Also, we enable auto-scaling to monitor tasks and automatically adjust capacity to maintain steady, predictable performance. To attach the secure communication, the ECS service has been deployed in private subnet, which can prevent the direct access of the public. Besides, we also attach net gateways in the public subnet to talk on behalf of the ECS service. Therefore, the traffic from ECS is able to reach the public subnet and send logs to our CloudWatch. Then we deployed the certificated application load balancer to allow traffic from the public to reach our containers. The users can access the target group through it and forward the request traffic to the container service. This architecture allows our application containers to be safely isolated from the rest of the internet, but they can still initiate communication with external resources through net gateways. Very exciting. Our project also uses AWS CloudWatch and Grafana for monitoring and logging. Next, I will talk more about the CI/CD pipeline of this project. Thank you. The Bitbucket stores all the code files from our developers. A pipeline will be triggered while the code is merged to the main branch. Then the AWS code pipeline will run the YAML file to execute the pipeline steps. For the front end, the build artifacts will be uploaded and deployed to a specific S3 bucket. Then CloudFront will be set up to deliver the web contents to the users. For the backend, pipeline will dockerize the files and then push the images to the ECR. Then the new ECS task will be created using the latest Docker image. In order to make provisioning automated, faster, and repeatable, we have codified our infrastructure as code by Terraform. That's all the content of our presentation, and thank you.
Thank you, Team TechMaster. Let's welcome our Team 5, Heartbeat. And at the meantime, Team 6, Omni, please get ready.
Just making sure everyone can hear me. Can you see my PowerPoint? Cool. Right. Okay. Cool. Hi everyone. Thank you for being in this session. My name is Roy, and I'm the team leader of How to Beat Our team consists of 6 developers, 3 DevOps, and 1 BA. And this is our project, Virtual Queuing. So what exactly is virtual queuing? Virtual queuing is an application that helps franchise restaurants to manage their customers' queuing experience and also optimize their services using the data collected from the queues. So as more and more franchise restaurants get into the market of down under, we feel that some of the restaurants still using the traditional way to manage a queue experience, like pens and papers. So we felt that we might be able to use our capabilities to develop something both easy and able to enhance the overall experience. So what are the main features of a virtual queuing? So let me just give you a brief showcase in our main dashboard. So this is our main dashboard. As you can see, I log in on the bottom left corner as the manager of the restaurant. I made a restaurant called Lucia's Dining on the top left corner. And the left-hand side panel is the information panel, and the right-hand side is our main dashboard, where you can see all the queuing customers in the list. This is where you get able to just perform the CRUD operation, update status, send text messages, and so on. But 2 of our outstanding standout features is SMS integration and data dashboard. For SMS notification, we use Twilio's package to automatically, when the customers enter into the system, it's automatically sent through the current queue number and its estimated wait time into the system and send a message to the customer. We can also manually send through the text message using the button on the platform when the queuing number is getting closer to getting serviced. And the other main features we have is the data dashboard. With the data dashboard, the restaurant can log in as a user and filter using the top right-hand corner filter dropdown with 3 different time periods to be able to just filter out information that is useful for them to optimize their service. So these are tech stacks. We use the traditional MERN stack, Mongo, Express, React, and Node.js for our front end and back end. For front end components, we use style components. We use JSON Web Token to verify our users' login and sign up requests. We use Twilio for SMS messages. We bundle everything using Vite. We use frame of motion for animation, and we also use for the content management, for the state management, we use Context API and React hooks. And we adopted agile development for enhancing our development experience. With this, we typically use the first 2 weeks for resource allocation. So we find out all the information about our developers' capabilities, times, and their programming skills. With that, we are able to just iterate through the following 3 versions of our application for the following 12 weeks. So that all leading up all the way to today's showcase where I can have the final product to showcase. So instead of me going through all the nitty-gritty details of the application, I'm just going to give you a brief showcase on a video we made. All right, thank you. Just going to go back to the PowerPoint. Okay, so for future developments, we feel that we're in a very vibrant team environment and everyone is pretty close to each other. So we will continue to develop and add more feature to it to make sure this product is going to get continuous improvement. And let's revisit our team structure. So I just want to share a bit of our experience in terms of the development experience on this project. I'm feeling very proud that we built this application from the ground up. As we are all rookies, complete newbies in web development, career switchers and students, we made a very early on decision that we want to build something that can actually tackle real world problem, but at the same time, making sure every one of us has exposure to aspects of web application development, such as front end, back end, and also utilities. With that in mind, myself, although being the team leader, I provided very limited dictatorship in terms of how this product is going to look like and how it's going to feel. So in every planning session of us, whenever there's a decision to be made, a topic to be brought up, every team member has their say, could vote and determine whatever the UI is going to look like and what feature is going to be included in the system. So I believe it's pretty fair to say that every one of our team members own a portion of this project. Although this is very time consuming to set up in the very first place, I believe that the diversity of the decision making make our project a little bit different, either good or bad, to some of the other commercial products that you can find over the internet. And I must say, I feel really lucky and that I'm in a team where everyone's just enthusiastic throughout the process and everyone's just taking responsibility to contribute to the app. Okay, so this sums up the contents for developers. So please allow me to pass it over to Jessie to go through the DevOps contents. Thanks, Jessie.
Thank you, Roy.
Sorry, I'm just gonna, here you go.
Yep. Good afternoon, everyone. My name is Jessie. I'm the DevOps in our team. It's a great honor for me to introduce our architecture, CI/CD, IAC, and the monitoring part of our project. We implemented a single region 3-tier architecture for the website. For our front end, we used S3 bucket to host the static website and use CloudFront to accelerate content delivery and use ACM to secure network communications. We also create S3 cross-region replication bucket to save the data in another region in case a disaster hits Sydney. Our backend was deployed to ECS Fargate. We have 3 Fargate containers in 3 availability zones, and all the containers can only accept traffic from load balancer to achieve high security. We deploy a net gateway in a public subnet so that containers in a private subnet can connect to services outside the VPC, but external services cannot initiate a connection with the containers. And auto-scaling policy will also apply to our backend to ensure we have the correct container number available for handling the application load. And for the database layer, we are using MongoDB as our NoSQL database program. We choose Jenkins as our CI/CD tool. For the front end, we install package, test the code, build artifacts, and copy the artifacts to S3 bucket. For backend, we use Docker file to Dockerize backend code, push the image to ECR, and Fargate can use the image to deploy our backend. If you see below screenshot, we have 2 environments. UAT environment pipelines would be triggered automatically when new code merged to main branch, while production environment pipelines would be manually triggered when all the quality check passed in UAT environment. We also use Jenkins to run Terraform and deploy all the resources in AWS automatically. In this way, we can execute Terraform command in a continuous deployment pipeline instead of team members manually updating the infrastructure from their own computer. When write Terraform file, we adopt below guides to achieve good practice. First of all, keep the state file secure. State file is significantly important for Terraform project. So we keep our state file in S3 bucket, which support encryption and backup. And we can also control the access by using bucket policy. Secondly, lock the state file using DynamoDB. This way, you can prevent concurrent edits to state file and help everyone in the team share the same view of the infrastructure. The third point is to use modules everywhere possible. It will lead to more code reuse and less repetition. Fourthly, separate environment. Our project have 2 environments, UAT and production. So we separate them in different folders in their own bucket. Last point is use consistent file structure to improve the effectiveness of team collaboration. For monitoring, we use CloudWatch to collect required metrics and use AWS Grafana to monitor performance of our website, including response time, availability, error rate, and saturation. That's all for DevOps part, and thank you for listening.
Thank you. I think that sums up for our presentation.
Thank you, Team Heart of Eve is really wonderful. And let's welcome our Team 6, Omni. Well, at the meantime, our last team, Court Canva, please get ready.
Okay, can you hear me? Okay, let's get started. Good evening, everyone. We are Team Omni. Let's get started with a short video to introduce our project.
Hey everyone, here's a video for Omni, internal management system for jracademy. When information stored in the system is the student information. Students can make orders online and they are related to course information, and we can set timetable for different courses. The other category is staff information. Staff can send posts in their daily work. When they need to take leave, they can also apply. Now we will see how to operate the system. After logging, you will be able to see the management dashboard. If you click orders, you can see all the orders from jracademy. If you click post management, you can create post. You can see the saved or archived post. In the course management, you can create a new workshop with some details. If you go timetable management, you can add a new timetable. You can also view the staff information at the staff. And you can view student information and use search or filter. In the My Leave, if you request leave, you can add some details and attach a sick note. After it is confirmed, it will appear in the pending list. Here's the tech stack we used, and here's the resource we deploy in AWS and pipeline we used. Thanks for watching.
Thanks for watching the video. Let's have a short introduction about our team. We have 4 team members in our Omni team and the tutor group. Lee and Lina are developers, and I'm Siobhan as the business analyst in the team, and Catherine is our DevOps. We applied Agile methodology in Omni. We spent 3 months and mainly focused on 3 features: My Leave, Leave Management, and My Staff. Omni is the management platform for just internal staff. Through the Omni platform, HR, operation, marketing, and sales specialists can manage their own business. In this roadmap, former team completed most of the job, and our team added few functions. And this is the second project roadmap. And in this roadmap, this is many responsible, and we developed 3 main features to help HR's management of employee information and leave taken in a digital way while providing public holidays and an auto leave calculator for reference. Besides, we create a feature to help employees from other departments in JR to make the leave application through Omni. Creating these features will make it fast and easy for the staff to apply for the leave, as well as the admin to approve the leave and staff management. It not only accelerates the efficiency of the current leave process, but also enhances the company's management of the talent. Okay, and about our timeline, we spent 2 sprints in the first feature, leave management, and 3 sprints about the second feature, My Leave, and the final, we finished the staff management in 1 sprint. And this is the Gantt chart for our project. We completed pretty much everything about what we have planned. In the future, more functions will be added, such as employees signing the account. Next, our developers and DevOps will introduce the tech stack about our project. Welcome, Lee.
Thank you, Jimon. Hi, everyone. This is Lee, one of the developers in our team Omni. I was meant to have my cameras on, but I couldn't log onto this Gather space with my laptop today, so my apologies. So I'll be giving a brief of tech stack we use and the staff leave management, which is one of the most important functions that we developed for this project. So for front end, we are using some of the most popular tools in the market so far, such as React, React.js, Redux Saga, and Design TypeScript. We use Keystone as our backend framework based on Node.js, Mongo database as data storage, and Bitbucket for the version control. So as we've seen in the previous video, here on this leave management landing page, a user is able to find out when did this user come on board and what are the remaining leave buttons as of now. By clicking the request leave button, a user can then choose a leave type, start time, end time. By clicking OK, the system will be able to work out what the leave hours will be, given the period and the user's working arrangement, as well as public holiday related to the user's location. After leaving a comment and hit confirm, we'll see this particular leave request has gone through to the backend and be populated in the table underneath. And the users can always come back to modify or delete this request. So the same request can also be seen by HR manager, who will also see the leave request lodged by other staff from the same organization, where the HR manager can choose to approve or reject any request, which can also be done in bulk. So to make all of this possible, we've created a fully customizable data structure for working schedule by defining specific weekdays, work times, break times. In that way, we have enabled the employer to be very flexible in negotiating the working arrangement with potential employees, which is also flexible enough to cater for any kind of working schedule that can possibly be in the future. So now I will be handing this over to Lina, who will introduce the way we create a user and the way we create a working schedule. Thank you.
Thank you, Lee. Anyone can see my screen? Thank you. Hi, everyone. This is Nina from Omni Group. Today, I'm very glad to demonstrate some pages of our team developed in this project. So first, as an HR, if you log in successfully, oh, okay. Can you hear me? Staff management page. So if you are HR, if you log in successfully, you can manage all the staff's information in this staff management page. So you can add a new staff, or you can edit more details. So this staff detail page, you can say there are 4 parts: the basic information, employee information, working schedule, and the school information. I want to say the working schedule part is one of the most challenging things for our teams. We discussed, we redesigned, and finally we improved it to a very, very flexible working schedule, just like Lee mentioned about. Next, I want to talk about other things. But first, let's go back to my leave page. So as a normal staff, I want to check my remaining annual leaves and the remaining personal leaves before I apply a new leave request. These hours are all calculated according to my commencement date and my working schedule and the current date. Pay attention to these numbers. And let's go back to the staff page to make some changes. We found the staff, Nina. Where's Nina? Here.
go to edit it, and we found the commencement date. We change Nina's commencement date to another date. Yeah, and we can add the 1 week day. So Nina work only 2 days now. Save it. Yeah, if we go back to the My Leave page, yeah, we can see the hours are automatically changed here. Yeah, so that's how these 3 parts working together. First, the HR add new staff. Second, the staff apply for a new leave request. And finally, the HR can view these leave requests, choose to approve and reject them. Well, that's all I'd like to present today. Thank you. And let's move on to our DevOps, Catherine.
Thanks, Lina. So, everyone, I'm Catherine. Now, please let me introduce the DevOps part of Omni. So here's our architecture in the AWS. We set the domain from root 53 for the website, and it requires the ACM manager to create valid SSL certificate. Then we create a CloudFront distribution so the content delivery of frontend can be speed up. The root 53 is connected to the virtual private cloud through the internet gateway, and the VPC is divided into public subnet and private subnet. So in the public subnet, we set NAT gateway and load balancer, and in the private subnet, we set our live server and stop server, and they're also called blue server and green server. So one is for the daily work, and one is for the maintenance and backup. It can also be used as a replacement server when there's a downtime. And these EC2 services provide this API operate the data in some specific schema stored in the MongoDB Atlas cluster. And that's how the backend service runs. We also use serverless feature, mainly contributed by the Lambda function. So for the Lambda, it is triggered by the API gateway, and it is connected to S3 to load results. And for email services, we use a general architecture. So the Lambda will pull the message from the AWS messaging queue services, SQS, then it be sent to the SendGrid, which is a SMTP provider. And this reliable sender proceeds to the GCP API to send emails, as we have forgot password email service in Omni. For the monitoring part, we currently have CloudWatch as a centralized location to view the performance status for the Keystone backend. We stream some log groups to the Elasticsearch, and then we create the indexing Kibana dashboard with some patterns. We're also planning to add the Prometheus and Grafana to visualize Lambda and server metrics. So in this slide, we'll see the CI/CD and pipeline for Omni. For each pipeline, we have UAT and production version. There are 3 types of Jenkins CI/CD. So for the front end, the change of front end repository will be published to the Jenkins server. In the workplace, the package will be installed and code will be built and tested to upload to S3. For the backend pipeline, it builds a Docker image, upload to ECR, then send to the service cluster. And for Terraform pipeline, it will perform the operation of the Terraform init plan, and there's also a conditional statement of destroy. We deploy several models. For example, ACM, CloudFront, S3, EC2, and Lambda. For Jenkins server, we're using the jrAD user and group management for the single sign-on authentication. And we're also using Vault to store the AWS credential and some environment variables to enhance the security. That's all of our presentation. Thanks.
Thank you, Team Omni. Thanks so much. And let's welcome our last team, Core Canva.
Yeah, everyone is ready. Okay, let's start. Hi, everyone. Thanks for your time. I'm Ethan. Our team project is called Canva. The production and the UAT link is shown here. Welcome to play around. In the beginning, let me introduce our team first. We have 11 developers and 6 DevOps and 1 BA, 1 UI UX. Yeah, our team members' LinkedIn link is shown here. Welcome to contact us. And we work together as one team. Yeah, today our content gonna separate to 8 parts. Introduction of product and the demo. After that is our tech part, also DevOps part, and also future improvement. Okay, let me show you a player video for you and to introduce our product. Thanks for watching. As you can see, it's our landing page. Yeah, it is built by WordPress. Yeah, our product goal is to provide a platform to help our customers to build a high performance code for their backyard. Let me show you our solution. Our customer can choose the code from the blueprint. Yeah, we have 6 standard design for them to choose from, and like the small code or pro hub code. Yeah, they can customize the color they like. Also, at the bottom left, the tile calculator will calculate spontaneously the number of the tile needed for each color. The calculator also will help the stock management. On another side, the quotation will instantly update the price. The price is based on the delivery fee and the tile price plus 10% GST. We designed a slide bar for our user to change the size of the border. As you can see, the border on the map will change. Also, the tile calculator and the price will change instantly. Okay, pay attention. Let me show you again. 3, the part will change spontaneously. Yeah. Also, we provide the undo, redo, and the reset function for our user. So for a clearer look, you can turn the ruler off or on, and then you can rename your design. After that, you can download your design as a PDF. Okay, we also provide 2 ways for our user to sign up and log in. First one is continue with Google, and then second is continue with the email. You just simply tap your email here. Our system gonna check it is a new account or not. Yeah, if it's a new account, gonna jump to here. It created a new account, and then our system gonna send the 6-digit number to your email. Please check here. Now you sign up successful, and then after that you can save your design to the folder. Yeah, all our data basically is from the backend. So we also provide dashboard for our admin to manage all of them. Here you can see it's our code page. Yeah, you can see it's our preset data for the 6 blueprint. You can click any one to check the detail and to editing the value. Also, can add a new code. Yeah, that's our demo today. Barry will continue next step.
Thank you, Ethan. This is Beryl. I'm going to introduce our structure. As we can see, this is our front-end stack. We chose Next.js for the framework, because our core feature is image related. Chakra UI is our component library because we allow users to design based on canvas. And we customize our page layout, starting with color, button, and model. Then reuse them for the whole page. For code drawing, we use Canva as a drawing tool. This is our core unit, so will be introduced in detail later. And both front end and back end, we also use a test library to ensure we have a good quality code. Our test coverage is more than 70%. By the way, at the bottom left, here's our front end GitHub link. It is public, so welcome to view our code. Now we can have a look at our main feature, as the PPT shows. Firstly, we separate each part of the code, such as 3-point area, key area, circle area, and so on. Then we draw them as small and reusable components. When we draw the whole code, we assemble them together, then layer them, flip them, or cut them into a specific dimension to build different shapes of codes we need. The code dimensions are also drawn by Canva. They have been designed to change automatically according to the code size. The code display size will be responsive by window size. The smallest screen size we allow for code Canva is 8 minutes. After drawing the code, we're going to introduce our highlight feature, tails counting. This feature is also reusable. Firstly, we define the code space and scan them as squares, which is the same as tile size. Then we find each square color as RGB type and convert them to hex type. Finally, the tail color and quantity will be calculated accordingly. For the backend stack, as the screen shows, we use them to connect with MongoDB. Then use Docker to pack as images and send them to AWS ECS. Here's the GitHub link for our backend, which is also public. And the next page is about our GitHub workflow. We strictly follow this process, and each feature will be reviewed by at least 2 team members before it is merged into main branch. Code will be also refactored once a week to improve our code quality. Apart from code reviewing, we use Agile workflow to manage our work in progress. As the PPT shows, it is our Notion board. We follow the Scrum sprint cycle to have weekly sprint ritual at the first 7 weeks. Then we change this weekly sprint to fortnight sprint because as the project progresses, features are more complex than they're in the beginning. We would like to display more completely content in the sprint meeting. Next, we have Kiki introduce the DevOps part. Welcome, Kiki.
Hi everyone, I'm Kiki. Now let's have a look at the infrastructure overview. We have deployed Jenkins on the EC2 instance, and we put front-end static files on the S3 bucket. Users can access CDN by using HTTPS, and then they will be redirected to S3. For the backend, we are using ECS Fargate to run Docker image, MongoDB for the database, and AWS Grafana for the monitoring tool. Next, let's move on to the highlights of our project. So we have 3 worth mentioning highlights. The first one is cost. We have set up rules on the AWS CloudWatch, which will trigger Lambda functions to start and stop EC2 instance on a schedule. This way, we can reduce EC2 usage and save cost. The next highlight is deployment rollback. We have set up rollback pipelines on Jenkins that can roll back front end or back end to a dedicated version. And the last highlight is security. We are using AWS Parameter Store to host secrets and credentials. We have also configured web application firewalls to protect load balancer and Route 53. Next, Sunny Lin will explain the CI/CD pipeline workflow and Terraform.
Thank you, Kiki. Hi, everyone. I am Sunny Lin. We have configured multi-branch pipeline on the Jenkins. When dev push source code to the GitHub, it will trigger those pipelines. For the front end, it will automatically build static web page file and transfer to S3. With the CDN, global user can access our web app with less latency. For the back end, it will build doc image, push image to AWS ECR, and deploy to ECS bucket. Deploying tasks into different availability zones with application load balancer, which enhance fault tolerance and availability. Enable auto scaling to scale up and down based incoming traffic. It's worth mentioning that health check standard has been configured on Jenkins and GitHub. Dev can check pipeline standard on the GitHub. It is also a requirement to merge code to the main branch. We leverage Terraform to achieve infrastructure as code. Holding the code in the GitHub with Jenkins pipeline, we can provision and update resources for backend, front-end database in one click. With different parameters, we can apply consistent infrastructure for UAT production environments. We also use S3 bucket DynamoDB as remote backend for the team collaboration. Remote state files are protected by S3 access control. Next, welcome Sunny Yang to introduce Monitor.
Hi everyone, I'm Sunny Yang. Regarding the monitoring part, we use AWS Grafana as a tool for making dashboards that help the developers keep abreast of the program health and understand the user. It's worth mentioning that developers can directly view the logs data through the Grafana without logging into the AWS. The dashboard of our project is mainly divided into two parts, metrics and logs data. Based on 4 golden signals, we use AWS CloudWatch to collect the data and make metrics. Meanwhile, we connect the Fargate to Loki through the Cloud Grafana and FluentBit to collect the logs data and finally create the dashboard in the Grafana. In addition, if the data is abnormal, the AWS Grafana will send a warning message to the DevOps team through the SNS and email. So let's come back to Ethan to talk about our future plan.
Oh, thanks for Sun Yang. Yeah, for the future, we will give our user more choice about the code, and also we will provide the template and friends chat management. Thank you for joining our presentation. Yeah, that's all our present.